In this lecture I have to discuss about the optical fiber characteristics and the classification. In earlier lecture I have discussed about the total internal reflections and acceptance angle with the numerical aperture. So how basically one can explain the total internal reflections by using the two mediums and the acceptance angle related to the optical fiber, and then numerical aperture. And numerical aperture we discuss in terms of the acceptance angle and the refractive indices of the three mediums. One was the air, where we have basically that optical fiber is kept. Second is the refractive index of the core, and third was the refractive index of the cladding. So in earlier lecture, as I told you, that we have discussed about it, and now the point about the characteristics of the optical fiber and the classification. When we say that classification means we are categorizing the optical fiber on the basis of refractive indices. So there are main two. One is the step index profile and second is the graded index profile. And then further we categorize on the basis of mode. So as I told you that on the basis of index profile, we categorize it into two, that step index optical fiber and the graded index optical fiber. Then on the basis of modes, that single mode step index optical fiber, multi-mode step index optical fiber, graded index, multi-mode graded index optical fiber. So like this, these are three. Multi-mode basically carries with the graded index and step index optical fiber, and single mode is possible only with the step index optical fiber. So this is the categorization. And now further some point related to the characteristics of the optical fiber. That characteristics of the optical fiber basically depends on some factor, but these factors are: number one, composition of the optical fiber, means the refractive index of the optical fiber. So if one have to characterize the optical fiber, the number one is the composition of the optical fiber. Composition means the refractive index of the core. Second is the type of light introduced into the fiber, the wavelength basically which we use for the optical signal into the optical fiber. So first is the point of composition of the core, second is the wavelength, and third is the diameter of the core and length. So these are mainly three points, three parameters to characterize an optical fiber. Number one, composition, second is the wavelength, and third is the diameter of the core and length of the optical fiber. So on the basis of this we say that optical fiber, when we are saying the title is this fiber characteristics and classification. So as I told you that characteristics of the optical fiber is determined by the composition of what material basically we have used for the core, that means the refractive index, and one basically through the N1 we define the refractive index of the core. So N1 is the refractive index of the core. Second point is about the wavelength, type of the light, that is wavelength, and third point is the diameter of the core. The diameter of the core, that is defined by 2a generally, where a is the radius of the core. So these are mainly 3 points by which one can characterize the optical fiber. And now the classification of the optical fiber. When we talk about the classification, we see that number 1 is step index optical fiber. Number 2, graded index optical fiber. Graded index optical fiber. This is also step index optical fiber. So these are two basically categorized on the basis of index profile. So how one can define the step index optical fiber? So, and the second point is related to the graded index optical fiber, and then further modes on the basis of guided modes, basically, that is single or multi. Single mode or multi modes. And on this basis of the combination of these, further the optical fiber single mode step index optical fiber. Number 2, multi mode step index optical fiber. And number 3, multi mode graded index optical fiber. So we generally play with these 3 types of the optical fiber. So this is the classification of the optical fiber: single mode step index optical fiber, multi-mode step index optical fiber, and the graded index optical fiber. So now the point is how one can categorize and or can differentiate between the step index optical fiber and the graded index optical fiber. So the first point about the classification of the optical fiber is step index optical fiber. So I am making here this step index optical fiber. So as name indicate that step index optical fiber. We know the construction of the optical fiber. This is the central part, which is known as the core. This one is the central axis of the core. So this is core. Refractive index of the core is M1, and the second part is cladding. This is cladding, and refractive index of the cladding is N2. So in case of step index optical fiber, the index profile of the core and cladding basically determine the shape of step index optical fiber. So in step index optical fiber, the refractive index of the core remain constant. This remain constant up to the core cladding interface, and then after it drastically abruptly change at the core cladding interface. So the point is about the refractive index. Refractive index of the core material remain constant throughout the core. This is the central axis, so both the side of it, upside and downside, refractive index is n1. But when it reaches up to the cladding, it abruptly change. A sharp change basically be observed, and that can be explained on the basis of this picture. Like this, and this is the chain. So in terms of these steps, these are the steps. It ends here and then it sharply increases. So in step index optical fiber, the refractive index of the core remain constant throughout the core and then abruptly change at the core cladding interface, and that is N2. And we already know about the relation of this N1 and N2. N1 is always greater than N2. So N1 is the refractive index of the core and N2 is the refractive index of the cladding. So this is the condition. So this is our first type of optical fiber, that is step index optical fiber. And now the graded index optical fiber. Graded index optical fiber. So this optical fiber is defined on the basis of index profile, and the structure is almost same. This is the core, central axis of the core. This is cladding. Core refractive index is defined by N1, and this one is cladding to protect the core, and refractive index is N2. The difference between the step index and graded index is about only the core. Here the refractive index of the core remain constant, but in graded index optical fiber, the refractive index of the core is maximum at the central axis, and then it decreases gradually up to the core cladding interface. In case of graded index optical fiber, the refractive index of the core is maximum at the center, and from the central axis, from this point up to the core cladding interface, it decreases gradually, right? So the maximum refractive index is here, and then it is decreasing gradually, and here at the core cladding interface it becomes N2. So the refractive index here, maximum point is N1. So on the basis of index profile, one can define that N R, this is the radius of the core, this one is the radius of the cladding, A and B respectively. A is the radius of the core, B is the radius of the cladding. So here, as I said earlier, that refractive index is changing with respect to distance, with respect to the radial distance. So N is a function of R, and this can be defined as NR is equal to N1 is square root 1 minus 2 delta 2r upon d whole square. This is a square. So here d is equal to 2a. D is the diameter of the core and a is the radius. R, this radial distance is less than a. That means we are defining the refractive index of the core. And when R is greater than a, it means we are defining the refractive index of the cladding. So N1 is square root 1 minus 2 delta is equal to N2, and here R is equal to or greater than E. That means we have defined the refractive index of the cladding. And for the gradient index optical fiber, the numerical aperture is equal to square root of n square r minus n2 square, where nr is the core index at radial distance r from the core axis. N1 is the core index, delta is the this delta is the fractional refractive index. Fractional refractive index. D is the diameter of the core. D is the diameter of the core, and here I have mentioned 2. So basically this is the value of alpha. Alpha is the index profile for the core. So alpha is the grading profile index number. So I have considered here alpha is equal to 2, that means it is a parabolic. So in case of graded index optical fiber, if we select alpha is equal to 2, it means the index profile of the core is parabolic. So these are the basic difference between the step index optical fiber and graded index optical fiber. The main point is about the index of core, and here in case of step index optical fiber, the numerical aperture is defined as n naught sin theta a, where n naught is the refractive index of the air and theta a is the maximum angle, that is called acceptance angle, and this were equal to n1 square minus n2 square. Further, this can be defined as n1 square root 2 delta. So in case of step index optical fiber, one can define the numerical aperture by this way, and in case of graded index optical fiber, this is the way of refractive index and then the numerical aperture. So by this way we have defined the step index optical fiber and graded index optical fiber. And now the point is single mode and multi-mode. Single mode means when the signal travel through this core parallel to the central axis of the core. If all the signals are parallel to the central axis of the core, we say that it is single mode. Right? But if in addition to the axial ray which are parallel to the central axis, one meridional ray, this one at the extreme angle, that is theta A, and in addition to this other rays which enter through this acceptance cone known as multi-mode step index optical fiber. So all these rays basically which enters through the acceptance cone get multiple reflection inside the core. So by this way, so this is the multi-mode step index optical fiber. So the single mode, in case of single mode, all the modes basically are parallel to the axial ray, and in case of multi-mode there are number of light ray basically which enter through the cone, so at different angles. So this is the multi-mode step index optical fiber, and in case of graded index optical fiber, the light ray basically travel in this form. So this is the representation of multi-mode graded index optical fiber. Now, what is the difference between the multi-mode step index optical fiber and multi-mode graded index optical fiber? You know that the refractive index of the core is uniform in step index optical fiber. So there are two rays, one is axial ray, this one, this is parallel to the central axis, so I am saying this is the axial ray number 1, and the second ray which is extreme ray, this at the maximum angle, right? So I have to receive this signal at this particular end. The refractive index of the core is constant, so which ray travel faster, axial ray or the meridional ray or this extreme ray? If you see carefully here, the axial ray passes directly and the extreme ray gets multiple reflection inside the core, and because of that it travels more distance as compared to the axial ray and reach later as compared to the axial ray. So there is time lag between the signal. So to overcome from this dispersion, in graded index optical fiber, all these signals basically reach at the same time. The refractive index of the core at the central axis is higher, so the speed the speed of the light ray will slower as compared to this light ray which is near about to the core cladding interface. So in graded index optical fiber, the problem which came into the step index optical fiber for multimode case removed automatically by varying the refractive index. So now in the next point we have to check the other characteristics of the single mode step index optical fiber, multi-mode step index optical fiber and multi-mode graded index optical fiber. What are the dimension of the core cladding and how much basically they provide the attenuation and where we use these optical fibers. So it was related to the characteristics of the optical fiber. The characteristics defining of the optical fiber by the three parameters. Number one is the composition of the material, that basically gives the information of refractive index. Second is the operating wavelength, and the third is diameter of the core and length of the optical fiber. And in second section of the lecture you have seen classification of the optical fibers. We categorize it into three parts on the basis of index profile. So one was the step index optical fiber, second was the graded index optical fiber. In graded index optical fiber you have seen that refractive index of the core varies, and it is maximum at the central axis and then it gradually decreases up to the core cladding interface. So now the basic properties of the optical fibers. So in case of single mode step index optical fiber, this is single mode step index optical fiber. What are the characteristics? What are the basic dimensions of the core and cladding and then buffer coating? So these are the points in this particular section. So in A part, single mode step index optical fiber, the diameter of the core diameter is 7 to 11 micrometer. Cladding diameter is generally 125 micrometer. And coating diameter is 200 to 300 micrometer. Buffer jacket is diameter of it 500 micrometer to 1000 micrometer. And in case of single mode step index optical fiber, the numerical aperture range is numerical aperture in case of the step index optical fiber is 0.08 to 0.15. So these are basic dimensions of the core and cladding, and then the buffer jacket. So in case of single mode, the core diameter is very small, that is 7 micrometer to 11 micrometer. In general, they keep 10 micrometer, and the range of numerical aperture is very small, 0.08 to 0.15. So other properties, the attenuation. Now the performance of this optical fiber. Two to 5 decibel per kilometer with a scattering limit of around 1 decibel per kilometer at a wavelength of 0.85 micrometer. Bandwidth greater than 500 megahertz kilometer, greater than 500 megahertz kilometer. This is the bandwidth of the single mode step index optical fiber. Application. These fibers are limited, and these fibers, single mode step index optical fiber, are best suitable for high bandwidth and medium to long distances. जो application है, so high bandwidth purpose and for the medium to long distances, this step index optical fiber we use. Now the second one, B part, is multi-mode step index optical fiber, the dimension of the core and about the applications. So this is multi-mode. This is multi-mode step index optical fiber. The core diameter is 100 to 300 micrometer. So multi-mode step index optical fiber case, the diameter of the core is start from 100 micrometer, while in single mode step index optical fiber it was around 7 micrometer. So this is the difference. So diameter of the core is larger in case of multi-mode step index optical fiber. Now the cladding diameter, this is 140 micrometer to 400 micrometer. Buffer jacket diameter is 400 to 1000 micrometer. Numerical aperture in case of multi-mode step index optical fiber is 0.16 to 0.5. Attenuation, when we talk about the attenuation in case of the multi-mode step index optical fiber, it is 2.6 to 50 decibel per kilometer at a wavelength of 0.85 micrometer, limited by absorption and scattering. Limited by absorption or scattering. So these are the dimension of the core, cladding and buffer jacket, and then numerical aperture. Numerical aperture for the multi-mode step index optical fiber is increasing. Here this is 0.16 to 0.5. So if the numerical aperture of any optical fiber lies in this range, that will be multi-mode step index optical fiber. And now the multi-mode is graded index optical fiber. But before that, I have to mention the bandwidth of the multi-mode step index optical fiber. Bandwidth of this optical fiber is 6 to 50 megahertz kilometer. So if you check here, this is only 6 to 50 megahertz. Bandwidth is less as compared to the step index single mode step index optical fiber. There was 500 megahertz. So bandwidth in case of multi-mode step index optical fiber is 6 to 50 megahertz kilometer. And applications, these fibers are best suited for short distances, limited bandwidth and relatively low cost application. So for these short distances we use multi-mode step index optical fiber. And now the graded index optical fiber, multi-mode graded index optical fiber. What are the dimensions for the core, cladding and coating, and then about the numerical aperture and bandwidth. So multi-mode graded index optical fiber. Number one, the core diameter of this optical fiber starts from 50 to 100 micrometer. In case of graded, multi-mode graded index optical fiber, it starts from 50 micrometer and up to the 100 micrometer. cladding diameter is about 125 micrometer to the 150 micrometer. Coating number 3, ये coating diameter is about 200 micrometer to the 300 micrometer. And buffer number 4, the buffer jacket diameter is about 400 micrometer to 1000 micrometer. And the range of numerical aperture is numerical aperture is 0.2 to 0.3. So here in this case of multimode graded index optical fiber, the range of the numerical aperture is increasing. So this is 0.2 to the 0.3. Attenuation in case of multimode graded index optical fiber. So attenuation means loss in a kilometer. This is 2 decibel to the 10 decibel per kilometer. That is wavelength of 0.85 micrometer with generally a scattering limit. Bandwidth in this case, multimode graded index optical fiber, the bandwidth in this case is 200 megahertz kilometer to 3 gigahertz kilometer. And this is maximum in all the cases. As compared to the multimode step index optical fiber, the bandwidth of this optical fiber is maximum, that is the 3 gigahertz kilometer. Applications of this optical fiber: this is best suited optical fiber for short and medium distances with high bandwidth applications. So for the local area networks, multimode graded index optical fiber we use. So these were the basic points related to the characteristics of the optical fiber and classification of the optical fibers. And in this section, I have just defined some properties of the optical fiber in terms of the diameter of the core, the range of the numerical aperture, the bandwidth, and their application for the short distances or long distances.